Now let's discuss the equation number 6a. Draw a force diagram for a 900 kilogram car that exerts 5000 Newton of traction force on the level road while being opposed 1000 Newtons of friction drag forces combined. Friction and drag forces are combined. Okay, so right now let's shrink the object to a dot. Okay, and we know that there is a gravitational force on the on car by earth, and there is a normal force on car by road. And let's say that the car goes this way, then the car will have a traction force. And the car will have a friction force of friction. Okay, so here when we want to write the equalities, like the normal force and gravitational force, they are equal. Okay, but since the traction force is bigger than friction force, that's why we are not showing any equality here, because they are not equal. So on the vertical axis the forces are balanced, that's why we don't need to write the equation for it. Okay, or the equation is the equation asks just write the net force, that's why we don't need to write that. So write the net force equation for the car. So let's write down general equation: net force equals mass times acceleration. So let's do like that. Let's choose this side positive and this side negative. Okay, so right is positive, left is negative. So force of traction, let me put here F. Let me put traction plus, and force of friction as a vector sign equals mass times acceleration. Okay, force of traction is to the right, then that's why it's positive 5000 Newton, and friction force and drag force is combined, and this is to the left, that's why it's going to be 1000 Newton negative. Mass is 900 kilogram, and acceleration is, there's a question mark we are trying to find. So then 4000 Newton equals 900 kilogram times acceleration. And when we do the math here, let's do the math here. 900 kilogram, so from there acceleration will be, so let's divide it, 4000 divided by 900, it's going to be 4.44 meter over second square, or you can write the unit of it like Newton over kilogram. These are the same thing. So we, by the way, we calculate the acceleration of the car up here. So question number 7. The 3 modified Edwards machines shown below have blocks of mass m on frictionless surface, there is no friction, hanging from the string. When the blocks are released, they accelerate as they did in our lab. Okay, so let's look at the system, guys. Here, when you release the system, when you make a force diagram for this object, like all the forces are vertical direction, right? So on this surface, like this block can move only right or left, okay, right or left, but there is no force on the m, like in vertical direction, that make it to the right or left. The only tension force applied on it, and tension is because of the mass right here, okay. So the only mass that provide the force is these masses, okay. So that's why if he says which system has a greater net force, explain how you know. So whatever the hang mass, whichever has a bigger mass as a hang mass, is gonna have a greater force, okay. That's why system C has the greatest net force. Okay, so how can we explain that? Hang mass provide the net force in the system. So hang mass provide net force in the systems. So since system C, or let me put here like since, okay, let me put system C. System C has 2m hang mass is going to be, or it will have the greatest net force. So now, which system has a less inertia? So let's look at it. So for the less inertia, we are looking at, for inertia, the only thing that we are looking at is which one has a, like, we are just comparing the mass of it, okay. So which system has a least inertia, which means that less mass, okay. So less mass less inertia. So that's why if you look at here, like system B and C has 3m and 3m masses, but system A has a 2m masses, okay. So since system A has a 2m masses, that's why system A has a least inertia. That's why system A has least the least inertia. Okay, so determine the acceleration of each system. So in order to do that, I am going to show such a calculation here. I'm going to do some calculation here. So for system A, I have a mass of hanging mass is m, and mass times g is the gravitation force, right? Mass times g. So what is the total mass of the system is 2m, and I'm trying to find the acceleration of the system A. So let me write the equation for system B. So I have a 1m times g hang mass, and system mass is 3m, and acceleration of B. And now I have a 2m times g equals system mass is 3m times AC. So from that, when we do the calculation, you will get AA equals G over 2, and AB equals G over 3, and AC equals G 2G over 2. So by this way, we found the acceleration of each system.